You're here tonight for the presentation, Connecting the Dots. And this is all about developing a flyway strategy to conserve sandhill crane migration and networks in the Intermountain West. And our presenter tonight is Patrick Donnelly with Intermountain West Joint Venture and U.S. Fish and Wildlife Service. So welcome, welcome, welcome. I am Janelle Wicks. I am the Executive Director for the Friends of Malheur National Wildlife Refuge, and I'm so glad that you're joining us. If you've not been to one of our presentations before, we love being able to share great information about Malheur National Wildlife Refuge, the Pacific Flyway, some species of interest, and you can find videos on our YouTube channel at Malheur Friends YouTube. What you're going to expect this evening is about 45 minutes worth of presentation. We're going to have a Q&A session at the end that will last about 10 or 15 minutes. So I would encourage you throughout the presentation to type your questions in that chat box that you've already found, and we will get to them at the end. I will moderate a Q&A session. And if you go ahead and make sure you're muted throughout the presentation, and that's going to help keep the white noise down for Patrick and for anyone at home who might not have a strong Wi-Fi signal and gets disrupted in their connection. So again, get those questions in the chat box, stay muted, and enjoy the presentation. This is, again, Connecting the Dots, developing a flyway strategy to conserve sandhill crane migration networks in the Intermountain West. Patrick Donnelly is our presenter. He's a landscape ecologist working for Intermountain West Joint Venture and has been working with the Fish and Wildlife Service for over 20 years through the Migratory Bird Field Office in Denver, Colorado. So without further ado, Patrick, the floor is yours.
Thank you, Janelle. Let me grab a new screen here so I can share my presentation with you all. And so just a little more on my background. So as Janelle mentioned, I'm with the Intermountain West Joint Venture. I'm located in Missoula, Montana, in the University of Montana. I'm a faculty affiliate in the wildlife program here. And we do work all the way across the West from the Canadian border to the Mexican border, and even do a lot of collaboration down in Mexico with our neighbor joint ventures across the Intermountain or across the West. And for those of you who don't know, joint ventures were originally set up to support conservation for waterfowl across North America. What they wanted to do originally with joint ventures was pull people together to think about things in broader geographies that allow folks to consolidate partnerships to achieve conservation in ways that we couldn't do on our own. And so I'm one of a number of joint ventures that's across the West. We're the largest in the West. We cover portions or all of 11 Western states, but in places like Malheur National Wildlife Refuge, just to the south, if you go into the Central Valley of California, the Central Valley Joint Venture is there. If you go a little further to the west, on the other side of the Cascades, Pacific Birds Joint Venture is there. So they're just dealing with different geographies of migratory birds, not just ducks anymore. Now it's all birds across the continent of North America. So today's talk is to talk about some of the strategies that we have that really begin to connect those dots. Dots aren't just birds, dots are also people as well. So that's what joint ventures do. They connect people with conservation in important ways. And cranes are a really, really wonderful conduit to link people together, not only because they're something that's important for looking at wetlands and what wetlands are important in the West, but because we have a common interest. They're really a bridge to conversation for folks in the West. And so what easier thing do you have to say is conserving cranes and wetlands in the West? Who doesn't want to work on that? And so it's a great way for us to really make those linkages with people everywhere through sandhill cranes. So let me jump forward here to the next slide. Before we kind of jump into the full body of the presentation, I just want to kind of talk about a couple different people that really make this kind of research on sandhill cranes possible. And this is a couple guys right here. The person on the right is really what I'm talking about. This is Rod Drewe. Rod did the original research on sandhill cranes, his PhD work in the mid-70s at the University of Idaho, and wrote kind of the seminal paper on the Rocky Mountain populations of greater sandhill cranes in the West. And really, he laid the foundation for those birds. And for those of you who don't know, Rod just passed away just last week. And so he was a mentor of mine. I've known Rod for 20 years. And I just want to kind of mention him when I give this talk, because his work he did originally was really, really important. And in fact, what you're seeing right now is a picture, if you haven't been, that peak in the background is Caribou Peak. This is Grays Lake National Wildlife Refuge in southeast Idaho. And the gentleman you see to Rod's right is Ernie Kaut. Ernie is a biologist for the Canadian Wildlife Service. And back in the, I believe it was the late 70s, mid 80s, they were going through a project on the refuge where they were trying to reintroduce whooping cranes to the west to generate a second population. And so they're using sandhill cranes as surrogate parents to raise those chicks and teach them the migration route from Grays Lake to Bosque del Apache National Wildlife Refuge in New Mexico. And Ernie and Rod right here are actually taking sandhill crane eggs and replacing them with whooping crane eggs on this nest mound in Grays Lake National Wildlife Refuge. And so I just want to give a shout out to Rod and mention his name in passing. And hopefully if you guys have a chance, you can Google his name and learn more about him online as well. And the second person that's really important and critical to this whole story is John Taylor. I don't know if any of you know who John Taylor was. John was the senior research biologist at Bosque del Apache in New Mexico on the Rio Grande. And this is the place where the most of the Rocky Mountain population of greater sandhill cranes terminate in the winter. And John had this vision over 20 years ago, which really is the presentation and research I'll be presenting to you tonight. And John did amazing things with wildlife conservation in the Rio Grande, and cranes were a big centerpiece to the decisions and conservation practices that he implemented there. And John and I, for many years, talked about, not only working at Bosque, but actually working across the West to understand where these ecological bottlenecks might be, from the breeding range all the way down the wintering range. And we lost John a number of years ago, way too early. And so I often like to think about John, because John's really my inspiration for all this research as well. So if you do get a chance and want to learn more about what John's done down at Bosque del Apache, I really encourage you to Google his name as well and read about what he's done. Just an amazing person, and really still an inspiration for me as well. So just want to lay some foundations for some people that really all made this possible before we jump into everything. Just to clarify, there's different populations and subspecies of sandhill cranes across the continent. Most people are familiar with, say, sandhill cranes. They think about the Platte River in Nebraska, where you see thousands and thousands of birds staging in the spring on their way back up to breed in the Arctic and the boreal forests, all the way into Siberia. These are the mid-continent populations, the lesser sandhill cranes. What we'll be focusing on here are these areas in yellow, blue, and red. These are portions of greater sandhill cranes, their larger cousins, which occupy most of the west of North America. There's population segments that stretch up all the way into Alaska, the Pacific Coast population. We'll be focusing on these birds that are largely breeding in the Intermountain West and wintering in those places, and also down in Mexico a little bit as well. And if we look at this a little more closely in detail, we can see here this breeding distribution in green across three population segments we'll talk about here in just a moment. The Rocky Mountain population segment, which is this big green blob here. This blob right here encompasses the lower Colorado River Valley population. We know now through the work we've done and the work with Dan Collins, who's a colleague of mine, that these breeding populations actually overlap between the RMP and the lower Colorado River birds. So we have birds that are breeding in the same places, but they end up down here in the lower Colorado, or some birds end up over here in New Mexico on the Rio Grande. And the birds that are really linked to where you guys are talking about are these areas in Central Oregon. We also know that these birds stretch up into places that are further north in the northeast part of the state. And those birds are primarily wintering in the Central Valley. These are the Central Valley population segment of birds. So these are kind of the three segments we'll be talking about tonight. Again, all breeding in the Intermountain West, most wintering in the United States, but we do get birds that go down into Chihuahua in Mexico in the RMP segment, down into the highlands and the foothills of the Sierra Madre, and places like Casas Grandes and Bustillos and Babicara, which are really important wintering sites, not only for cranes, but for waterfowl and other shorebirds and water birds in the western part of the US Pacific and Central Flyway. So before I jump into talking about migration, I like to show some slides about what this landscape actually looks like. And I was fortunate enough about 10 years ago to take over as lead surveyor for cranes, the Rocky Mountain population, from Rod Drewe. Rod used to fly this survey every year, did it for over 20 years. When he retired, I got to take over his place. And so we do every fall, we jump in a plane and we fly around all these really important places in the West, and we count all the Sandhill cranes. Now, we only do this for the Rocky Mountain population. It's the largest population of three. There's about 22,000 birds in that population. So it's much larger than the Central Valley or the lower Colorado River Valley population. But the landscapes these birds occupy really remind you and are consistent from Burns, Oregon, all the way to this place, which is Bear River Refuge in southeast Idaho. Flood irrigated hay meadows are the primary kind of wetland surrogate that makes up the balance of the habitat these birds occupy during migration, but also during breeding areas as well. So this is just an example from the plane. We're flying over one of these areas where we're counting birds in the fall. And what the ranchers are doing now, they've cut all their hay and they're applying a second irrigation across that field to really charge up that soil, so when things melt off in the spring, that grass is ready and green to go, and they can maximize their production of hay in the landscape. This is an area coming off the east side of the Wyoming range. This is a riparian system. This is also one of the highest density sage-grouse areas in the continent, in the West. It's also a really important breeding spot for Sandhill cranes. So it's not just these big areas that are linked to flood irrigated agriculture. There's also these really intact natural riparian systems to support birds as well. This is the Star Valley. Again, it's a riparian floodplain system. Flood irrigation and ranching is core to what's going on here. Breeding birds here, staging Sandhill cranes here. You can see flood irrigation, and actually they've got cattle out here on this wet meadow within this landscape. Also a really important place for breeding waterfowl as well, not just Sandhill cranes. Star Valley, Wyoming, on the Wyoming-Idaho border. These houses over here are just in Idaho, if you're curious, and then the rest of the valley mostly is Wyoming. Grays Lake National Wildlife Refuge. This is where I showed you earlier, Rod and Ernie bending down, replacing those Sandhill crane eggs, the whooping crane eggs. This is a picture of a dry year. We'll talk about what drought and climate change means for these birds as well. This is the south end of the refuge, looking back up north. If you're a trumpeter swan person, you've been up to this area, this is where you see most of those breeding trumpeters. There's birds on the north end of the refuge as well, but when this is wet, this is where the majority of the birds are actually hanging out on the site. This is, again, Grays Lake, about mid-basin looking north. You can see Moose Island here in the middle, some low-hanging fog, giant clustering wetland system in southeast Idaho, which is really important for Sandhill cranes. Cokeville Meadows National Wildlife Refuge. September, it's pretty dry here, and you can see right now all these meanders from the Bear River. These are oxbow-based wetlands that are dry in the fall, but in the spring they provide excellent breeding habitat for birds. It's also a working refuge. You can see a lot of the area here has been cut for hay as well. That was part of the deal when they made this a refuge. They kept it part in working for cattle ranching. Ranching is one of the most compatible land uses in the West for wildlife. And if you have an alternative between ranching and subdivisions, we always take ranching because birds can make a living in these places when ranchers are producing hay and growing cows. We can grow birds there too. This next one is the Salt Creek. Again, continuing that theme, places that are good for sage grouse, good for ranching, and also good for migratory birds. The Upper Beaverhead in my state here in Montana near Dillon. This place stages the largest abundance of sandhill cranes in the West. There's over 2,500 birds here that stage here in September. So they're all massing here before they begin their longer migration down into New Mexico. And we count the majority of birds in Montana on this side each year when we're flying around looking for those guys in the ground. Another shot of the Upper Bear River, large plustrian wetland. This system is also really important for white-faced ibis. This wetland supports sandhill cranes, but also a large ibis colony as well, which benefit from the same kind of ranching flood irrigated types like you guys see in the Harney Basin. Ibis and cranes often go together in many of these places around the West. This is the Madison River Valley, just south of Ennis. If you're a trumpeter swan person, this is a release site for Montana. We count a lot of trumpeters that are being released here as well. And this is what the delta of the Madison River looks like just downstream as it goes into Ennis Lake. If you're a fly fisherman, you've probably been to this place before. It's another important sandhill crane site in the West. And if you've never been to the Upper Green River in Wyoming, again, big sage grouse place, but huge hay meadow operations, supports a huge number of breeding sandhill cranes as well. You can see here these big hay meadow systems interspersed with these willow kind of stringers where these streams come out of the Wyoming range and the Wind Rivers to support this really, really important place. Places like this right now in the context of the Colorado River, this all feeds the Colorado. So eventually the water you see coming off these important places for breeding sandhill cranes ends up in Lake Mead. And if you've seen Lake Mead lately, there's not a lot of water in Lake Mead. And so there's pressures to take places like this, which are doing flood irrigation and really creating these natural landscapes where flooding used to occur before hay meadows actually ever were on this landscape and cattle were here. It used to spread water out as it came out of the mountains across that entire floodplain. And it kept that place charged and green all year. Well, producers and ranchers do the same thing today, but now they cut the hay. Well, going into kind of looking at Lake Mead now, there's pressure to convert all these things to center pivots where we convert it not from flood irrigation, but to sprinkler irrigation. So we can take that extra water and put it in Lake Mead. Well, there's unintended consequences of that. We want more water in Lake Mead, but when we kind of disconnect this flood irrigation to more efficient sprinkler systems, we can also disconnect a lot of these ecological values, not just for cranes, but for cold water fisheries like trout. I mentioned ibis and other migrating shorebirds. It's not that we don't want to fill Lake Mead up with water, it's just we don't want to lose all of our important ecological kind of function ranchers are providing to us in these upper watersheds as well. So we want to be smart about our conservation. So Upper Green is an important place to make some of those considerations. This is the Upper Henry's Fork near Yellowstone National Park, another important place for breeding sandhill cranes. The Big Hole Valley in Montana, just south here in Missoula. And this is the Marsh Valley, just upstream from Pocatello in Idaho, another big place with a lot of flood irrigated agriculture. And I think this might be our last one. This is Blackfoot Reservoir in southeast Idaho as well, big staging area. You might notice here, there's a lot of cut barley in the foreground. Agriculture, not only from the context of some of the slides I've shown you previously with flood irrigated hay meadows, but also production of barley provides a really important food resource for migrating sandhill cranes. And actually they prioritize how they move through landscapes based on their accessibility to water and wetlands, and also their ability to access energetics value, calories from grain that's been left in the fields once they cut it here in barley fields. And so when they can find those two things close together, it's a good place for a sandhill crane to make a living when they're traveling between the breeding grounds and the wintering grounds in the Intermountain West. And this is one last slide here. This is near Dillon, Montana. Again, you see the Beaverhead River here. With grain close by, always an important requisite for sandhill crane migration. They're looking across the landscape. That was our slideshow of places birds like to be. So hopefully you have in your head now kind of an idea of what places cranes like to be when they're traveling across the West, what's important to them. The research I'm going to talk about today was first put forth in this document. You can actually go online if you'd like, and you can pull this document up. It's Priority Information Needs for Sandhill Cranes. It's a funding strategy, and it's provided by the Association of Fish and Wildlife Service Agencies. And so some of the funding that was made available for us to do this research was provided through this group here. AFWA is the acronym. And if you want to read more about what those priority needs are, not just for greater sandhill cranes, but for those lesser mid-continent birds I showed you earlier, all that's in this document as well. So if you want some extra credit reading, this is a place you can go to get some more information on sandhill cranes. Now, the idea behind the work we're doing, and part of the title of the talk tonight is connecting the dots and using big data. When I say big data, I think of things like Google and Facebook and giant servers with information on them. That is a way we can now leverage new information and new ways to analyze it to make better decisions on the landscape. And that's what this research really is about. The first part of the research is this right here. If you look closely, and you can see what it is here, this is actually a sandhill crane. It's in a sleeping bag. Once we actually rocket net sandhill cranes, we want to calm them down quickly. A really good way to do that is to put them inside a bag so they can't see and it's dark in there, and they don't really have as much stress when you do that. And what we do when we're doing that, we take some blood for some isotope work, but we also attach a solar charged GPS to their leg. And this is a way we can track birds up and down the flyway. These are collecting GPS points as birds are flying. And there's a couple of ways you can actually get the information. Sometimes that information can go right up to a satellite and it'll download to a computer and you can look and see where those birds are at. Other times it collects the data and stores it on that little chip on the leg of the bird inside that unit. And as soon as it comes into contact with the cell phone tower, it calls the cell phone tower and downloads that information to the cell phone tower and then gives it back to us. And so most of what we do now is we use the cell phone tower type of strategy where we have enough density of cell phone towers everywhere. We can always be in communication with our birds, literally through the process. Now, we link birds this way through technology, where we put instruments on birds, to landscape conditions. And this is a little view of wetted wetlands you can see in blue here. We use big data working with Google to map surface water continuously across the landscape with satellite imagery. So I can tell you what month a wetland is wet, and I can tell you if there's a crane sitting on that wetland or not. And we can take that imagery from those satellites, because Google puts it all in one big giant server for us. They've been collecting that imagery for 40 years. And so I can look back 40 years in time. I can take a time machine back to the 1980s and look at wetland conditions. And so it gives me a really, really good way to determine how things like warming temperatures and climate change are influencing these wetland trends that are important to cranes. And so we tie these things together and we can make some really good decisions on what places are most resilient to climate change and which ones are really most important for sandhill cranes. And if I only have $5 to invest in conservation, I want to invest in the best place. Now I can find the best place to make that conservation investment. That's part of the joint ventures model and rule I talked about at the beginning of the presentation, is making some of those good decisions with data and information. So if I jump to the next slide here, this is a colleague of mine, Dan Collins. Dan is another Fish and Wildlife Service employee. He's out of the Albuquerque office. And what Dan is doing right now is he is capturing crane, and we use rocket nets. So we bait birds in with corn usually, And we have a net with rockets tied to it, and we fire off the rockets and they pull those nets over the birds, and then we go in and untangle the birds, and that's when we put them in the sleeping bags, and we give them their GPS unit on their legs, and we let them go. And you can see the map here has a bunch of black dots around it. And sometimes you see a number next to the dot. That number indicates the number of cranes that were actually banded with a GPS unit and the location when they were banded. If there's no number next to the dot, that means there's only one bird that was actually banded there. But you can see most of the birds for this study were banded in the wintering grounds, either at Bosque del Apache National Wildlife Refuge or other places in the Middle Rio Grande Valley, south of Albuquerque. Some were banded around Wilcox Playa, some near the Salton Sea, the Lower Colorado River, and there's a number of birds kind of scattered across Idaho and Montana. There's a lot of birds here for your population that covers Malheur at Ladd Marsh Wildlife Area that ODF&W runs in the northeast part of the state, okay? That's where these birds kind of come from across the west. Now, we take all that information, and what we do with that information is we collect all the points. Remember, the birds are calling us back on the cell phone towers. And right here, you can see all the tracks those birds make between breeding up here in the north and then summering or wintering down here in the south. And here's our three population segments: Central Valley, Lower Colorado River, and the Rocky Mountain population, okay, three different colors. Now, this is the same information here in panel A, except the colors mean different things. The red dots you see are areas where cranes are breeding. The blue dots are where they're wintering, and the green dots are what we call staging areas. That's where they're stopping, and they're eating a lot of that barley as they're moving up and down the flyway. That's an important place. That's their flying J truck stop as they're moving up and down the flyway. That's what those green dots are. So we take all that information and we run some fancy statistics on that information. And we get this really funky kind of web looking map that looks like this. We see the same three colors: greens for Central Valley, reds for Lower Colorado, blues for Rocky Mountain. But now you see these little dots, and they're all connected with these lines. Well, these lines all mean something statistically, but what's most important about that is the size of the dot they're connected to. Now you see some dots are really big and some are still really small. Well, if a dot is really big, that means it's really, really important to maintaining connectivity between the breeding grounds and the wintering grounds. If I took that big dot away, cranes would have a hard time getting back and forth between those two areas. So this is a place where if I took my $5, I'd really want to prioritize going to these big circles first before I got to some of the smaller ones. And so that's what's really important here, is of all these sites that cranes use, there's only about a dozen of them that are more important than the others. You can see here during fall migration, this is panel B, is fall migration, the Harney Basin and the Warner Valley are important sites for maintaining connectivity during fall migration, according to the model. Other places here, this big dot is the San Luis Valley. Almost all the birds you see coming out of New Mexico utilize the San Luis Valley as a really important pit stop to get energy before they continue on their migration further north. And if you look over here in Nevada, this is Pahranagat Valley, near Pahranagat Valley National Wildlife Refuge, or Pahranagat National Wildlife Refuge, sorry, which is also really, really important for birds. And so we prioritize these areas for conservation before other things when we go through and do our conservation investments across the landscape. Now, inside of all these important areas, we know that wetlands are important for birds. Remember that time machine I mentioned a little bit earlier? We can go back in time with satellite imagery. Well, here's us today in 2020, or near us today. I went all the way back to 1984, and each of these different lines represents a different kind of a wetland that's important to a crane. And you can see these lines and the straight line going through it, they're all going down. That means wetlands are getting less wet over time. Over the last 40 years, we've lost about 20% of our wetlands. Now, we didn't lose them, they're just not getting as wet as they used to be because our snowpacks are decreasing, temperatures are increasing, and there's just less water to go around the West. And that's reflective in how cranes are impacted, because these important areas they need to fly back and forth are going away. So we look at wetlands to prioritize. We also look at things like grain. And if we just look at these two lines here, you can see once you get about to 2012, they're pretty flat. Now, what this tells us is that the barley that cranes need to migrate, which they focus on, really isn't changing much. So people talk about maybe we're going to lose our agriculture. Right now, we're really more concerned about losing our wetlands. Agriculture isn't limiting cranes. Wetlands are limiting cranes. So this helps us even focus more on those most important things across the West. And this is kind of a fancy graph, and I don't expect everyone to really understand exactly what it's all trying to tell us here, but what's most important here are these two things right here. This one that says grain area, that's the amount of grain, and distance to water. Cranes are really, really lazy. They want to roost in one spot and be as close to the grain as they can to get that energy. They don't want to fly very far. It's the same way when they fly from the breeding grounds to the wintering grounds. They want to take the fastest, shortest route. So conservation or migration efficiency is critically important. So when we think about cranes, it's really important to think about places that cranes actually want to utilize. And so let me switch over here to a model that we built. So this is a model for the San Luis Valley. Remember that really big blue dot I showed you guys? It was really important to cranes just a minute ago. Well, if I turn on spring migrating sandhill cranes in the San Luis Valley, I get this kind of funky looking heat map. What this tells us, areas that are red have the highest concentrations of cranes in the spring. Areas that are green and yellow have high concentrations. Blue has lower. Where we see no color, that means there's not many birds there at all. So this tells us where cranes are in the San Luis Valley. I'm going to turn this other terrain on so we can kind of see we're in the San Luis Valley. You can see the mountains now sitting around us. Now, I can take this information. This is all from those cranes we put transmitters on. I know where they're hanging out now in the springtime. I'm going to turn down this so I can kind of turn it off so I can see underneath it. Now I'm going to go here and I'm going to turn on surface water for April and March. This is a time when a lot of sandhill cranes are actually in the valley. So I can look really close here and see they're sitting on these wetlands. This is Monte Vista National Wildlife Refuge. And here's how many cranes are sitting on top of this big red blob is a place where there's a lot of cranes sitting on that refuge. So now I can look at this refuge and go, how are these wetlands doing? Are they staying wet or are they getting drier? Well, if I go to this different button right here, you're going to see some different colors now. Reds mean areas are getting drier. Blue means areas are getting wetter. So when I look at long-term using my time machine, I can tell you what wetlands those cranes are utilizing are actually staying wet and which ones are getting drier. So when we're doing conservation on the ground, I can make a smart decision and invest in the red areas to make sure they get wetter over time. And so this is a way to take technology and big data from 30 years ago and use it to answer questions today with good information. So we build these are actually apps you can go online and use. We give these to conservation partners and they go to places like the San Luis Valley and they make good conservation decisions with all this information. And that's what cranes really give us, is a way to conserve wetlands in the West that are most important for cranes and the ones that are most resilient to climate change. So when we do this, we kind of check all the boxes to determine where birds are, what's important to them, and ensure they're important in the future by investing in those places and keeping them wet into that same time period as well. So it's kind of a win-win-win situation for all the birds in the Mountain West. Now let me jump back into this slideshow here. We're getting towards the end of our time. One thing I want to kind of hit home as well, I've talked a lot about, you saw a lot of slides about ranching and flood irrigated agriculture. And there's some other research we've done in the past where we actually looked at how many of our wetlands in the West are linked to agriculture. And in fact, it's about 62% of all our wetlands in the West are tied to these flood irrigated ranches that we see. But if we take all the irrigated agriculture, and I mean all of it, all the center pivots that are alfalfa, all those things you see out there that don't really provide any wetland benefits, only 7% of our agricultural footprint provides wetlands. Now, if you're spending time in the Harney Basin, think of all those wetlands south of Burns, north of the refuge. Those are the places we're talking about that are critically important for migratory water birds. And when we think about what those are, we say, okay, we want to preserve agriculture for water birds. People think of row crops and tomatoes usually. We're not talking about row crops and tomatoes. We're talking about places like this. This is the Dragon Y Ranch on the upper Beaverhead. It's a big floodplain system that grows hay for cows, but also is a place that supports breeding sandhill cranes. And core to this Dragon Y Ranch is also a cold water fishery that grows West Slope cutthroat trout that people fly in from all over the country to actually fish for. And on top of just cows and fish, it supports migratory water birds. These are phalaropes migrating through the area as well on top of the site. And this is one of our marked sandhill cranes that are actually breeding on the ranch as well. So when we say agriculture, we're talking about preserving natural wetlands that are overlaying private lands that are critically important in the West, just like the ones that we see in the Harney Basin. They're no different than that really at all. I'm going to skip through some of this stuff because I want to give us time. We might get back to some of these slides at the end with questions that we have. But Janelle, I'm going to pause there and we can stop and take some questions and maybe get back to anything I missed given time. So.
Great, thank you, Patrick. We do have a question from Louisa, and she asked if the system for monitoring the sandhill crane movement is going to be or is tied to the Terra network.
Can she tell me what the Terra network is?
Sure.
I'll probably say no because I don't know what it is.
Louisa, if you want to unmute yourself and elaborate, we'd love to hear from you.
Okay, can you hear me?
Yes.
Yep.
Okay, the Terra network, I think that's the right name for it. It was crowdsourced this year. It's setting up a system of monitoring stations in people's backyards that is somehow going to link to some sort of devices on birds to, and it also listens to map migratory patterns for different birds. And I think they're going to be using the sound for the night sounds for migrating birds to figure out who's passing over when.
Right. So thanks, Lisa. That's a great question. This monitoring system is not linked to that, so it's independent. So each bird essentially has its own monitoring station. So we can get points and locations, and we can get speed and elevation at say 5-minute intervals over the life of that transmitter. We have birds that have been instrumented for over 5 years, so we have full migration cycles back and forth. There's another network called the MODIS network, which does something similar to Terra, where you can put small little beacons that are really, really lightweight. They don't really have all the instrumentation you would see on like the transmitters that I showed you with cranes. And when you get close enough to one of those MODIS towers, it records that bird actually being in proximity to it and gives it a heading as that bird moves away or from that tower. And there's been some talk about setting up networks continentally with MODIS. The problem with some of those sensors are that unless you really build a comprehensive network, you only get little snapshots of what birds are doing and where they are. And while that can be important for some small questions, you get to some of these really big landscape level questions and ecological trends we're interested in, it falls short until we reach some kind of critical mass. And so that could be maybe a decade or two away before we get there. At the same time, the transmitters we put on cranes are getting smaller and smaller and lighter. And so we can put them on smaller and smaller birds as well. And I think at some point those two lines are going to cross and we'll find the optimum way to get things going. But that's kind of where the whole technology is headed, at least in currently.
Okay, your answer reminded me, I think this Terra network is going to be linked to the MODIS network.
Yeah, I think so too, actually. I have been already made aware of the Terra products and read a couple articles and watched the Kickstarter receive funding, and it does look fairly interesting as a backyard science tool that is going to be connected to larger tools for scientists. So thank you for that question. I did pop a link into the chat box about the Terra, the Kickstarter link for Terra, because you can watch a video from that website. Okay, so Dolores is asking, how does the population in Sauvie Island fit into the picture?
So that population, I believe, is part of the Pacific Coast population. So they're coming down from Alaska, and they were not part of this analysis. They do intermingle with birds once they get to the Central Valley, but they weren't part of the larger network that were marked, so they were kind of outside the loop. But they use some of the same networks that those birds use once they get further down in the system, depending on where they're at. A lot of those birds are going up through the Willamette Valley and then jumping up through BC and around the corner to get back up to Alaska, but different population, subpopulation.
Great. And Ron from Klamath Falls asks, are the eastern greater Sandhill cranes being followed and located in the same way as the Rocky Mountain cranes are in your discussion?
So those are lesser Sandhill cranes, not graders, that are part of the eastern population and the central population, the mid-continent. And yes, they are being instrumented, and they've been studied for some time, kind of similar parallel tracks. There's different questions for different subpopulations and different bottlenecks ecologically. So the mid-continent birds are hunted pretty heavily, so they track them to determine how different groups are impacted from hunting. Our population, the RMPs are hunted as well. That's why we monitor them very closely. But with wetland drying in the West, we have concerns about how those birds can maintain their population long-term, given the way climate's driving things in the West.
Great. Well, that wraps up the questions that we currently have. If you found where you wanted to go, I think you were looking for something else you wanted to mention.
Sure. Let's, what I'd like to do maybe just to kind of hit home on what wetland drying and the trajectory of wetlands in the West really means. And this is some work we published last year. And what we did was, you can see here in panel A, it's a little bit sciencey, so I apologize if not all this is clearly digestible. But what you see here are some gray backgrounds and some red circles on top of them. These are all closed basin watersheds, like the Harney Basin, like Summer Lake, Goose Lake in your part of the world, all those places, Lake Abert. Those are places that occur across the West and are represented here. Great Salt Lake is one of them. And we want to understand over the past 40 years, what direction those lakes have been trending. Are they getting drier or wetter? And we found overall they're about 27% drier than they were, 30, 40 years ago. And if we look at the wetlands inside of those same watersheds, so think about what's happening upstream from Malheur Lake, between Malheur Lake and Burns, and we quantified all the wetlands that were there. They're actually 47% drier than they were in past decades. So the wetlands are still there, but they're just not getting wet anymore. And that's a critically important thing to understand. When birds that are occupying arid systems, water is critically important to breeding and migration and wintering. And when you think about why we haven't heard more about this in the West, why haven't we heard about things going away in wetlands? Well, the Fish and Wildlife Service does a really good job of monitoring wetlands across the continental US, the lower 48. And what they do is they go in and they say, okay, we're gonna look at this wetland, we're gonna come back 5 years and we're gonna look at it again. And if it's a Walmart parking lot in 5 years, we're gonna check a box and say the wetland is gone. Now, that's traditionally how we lost wetlands, through agriculture, urban development. But that doesn't really jive so much in the West. We have low density of people in most places. You think of Burns and Nevada and lots of Montana and Idaho. There's lots of places with not a lot of people. But if you think about what's being lost there, the wetlands are still there, but the water is gone. And so if we look at a map from one of these reports, the green areas show us where they're seeing declines in wetlands for the past 10 years, early 2000s. Well, look at the Intermountain West. There's no green except for the San Joaquin Valley in California. So according to their models, no one's ringing the fire bell here, because that wetland they go back to see every 5 years, there's no Walmart parking lot on top of it. It's just a dry dust bowl now. And a dry dust bowl doesn't breed sandhill cranes, phalaropes, or white-faced ibis, but according to the way we monitor things, it's still a wetland. And so understanding the context of what climate change means to the West is critically important. And that's why I showed you guys that map of the red, the white, and the blue. That is our kind of Rosetta Stone for determining what places are getting wetter and drier, so we can make those investments in the right places to overcome this lack of perspective. And we have more research coming out that's going to kind of turn this on its head and say, hey guys, we're not going to measure Walmart parking lots anymore. We're actually going to measure how dry wetlands are getting. And that's going to be our yardstick here in the West, because that's really what's most important to wetlands here. Just one last thing too, I wanted to mention, there are a lot of folks that are involved in these projects. And you saw all those places we trapped sandhill cranes around the West. Well, that means getting together with a lot of state wildlife agencies. And so these are a list of all those folks that were kind of involved in this process. I'm at the University of Montana, and I work out of the Avian Science Center, so that was really important as well. Places like Rocky Mountain Power, they're concerned about power line strikes and birds, so they invest in this stuff as well. And part of the avian power line network too, those are folks that are interested in how power lines affect avian populations, are part of this too. So if you're from any of these states, you guys are part of that whole bigger process, which made this whole research possible, and making our next kind of research endeavors possible too. I mentioned earlier in the talk, white-faced ibis being a really important kind of bird like sandhill cranes. We're getting ready this next year to mark white-faced ibis across the West in a similar way we've done sandhill cranes, to get to some similar questions, because white-faced ibis are experiencing really, really dramatic wetland declines as well. And we want to understand how those are impacting those birds and how they're responding across the West. And we'll likely be doing that inside the Harney Basin as well, working directly with the Friends Group and the refuge. So stay tuned for more information there. And Janelle, I don't know if there's any more questions, but we've got some time, I think, left for a few more.
Thank you so much, Patrick. We can, if you want to put any more questions in the chat box, I did want to share what Louisa shared earlier that directly ties into what you were wrapping up here with. And she shared that in the lower Treasure Valley in Idaho, while not a major crane use area and migration compared to other places, is losing both wetland and grain due to suburban sprawl, as well as changing precipitation patterns. Fewer wetter storms that lead to drier conditions counterintuitively. So, you know, personal observations interesting as well.
Yeah, and it's, when you talk to ranchers around the West, you know, they've been on that same piece of ground for decades, and they can tell you the same story that our data is telling us. We just use Google and big data to get there. They've been that monitoring station on that piece of ground for longer, and the satellite's been in the air, and they really confirm that same level of information. I will say that the San Luis Valley model I showed you guys of crane density and wetlands, we're building that for the entirety of the West. And so you can expect something like that coming out probably in the first quarter of 2022. And just for a quick sneak peek, it looks something like this is the Idaho beta version, similar we showed you guys earlier, where you can look at surface water conditions across all of Idaho. And if I zoom in here to the areas around Bear Lake, remember I showed you guys the pictures from the air around Bear Lake with all those wetlands? This is that same landscape. This is how wet it looks like in March. And so I can fast forward in March, and I can look at what it looks like in May. It's even wetter in May. And if we go to September, it's a pretty dry place. So it allows us to measure trends through time. but it also allows us to go back and look at resiliency. Remember the red, blue, and white, red's getting drier, blue's getting wetter. How these landscapes are responding to climate change are critically important as well. So if I've got someone on the ground working with a producer and they're trying to put a conservation easement in, they want to go to the blue places because those are showing us where things are climate resilient over time. And we can ensure that if we invest in those sites, long-term, they have a better chance of being productive than places that are currently red because they're already being stressed by climate through time. This will be available for all of Oregon. And so you guys will have an opportunity, if you are conservation planners, to incorporate this work into your own planning and make good decisions with it. And we hope you guys do. And we hope it changes the trajectory of the impacts you're seeing from climate change in a better way. So that's kind of our goal for the JV to make those things positive as much as we can.
Awesome. Thank you so much for sharing that, Patrick. We did have one other question from our friend Dan. I was wondering if you had any thoughts about beavers, and I would imagine this is in relation to their effectiveness for restoring wetlands.
Yes. So we've done some research. I've been part of research where we've used Beaver Dam Analogs, short the acronym BDAs. Basically, it's slowing water down, keeping it in the floodplain and charging up that floodplain system. When we do that, what we can do is when we keep water in the floodplain, we keep things greener and we keep roots in the water longer. And beavers are an amazing conduit to that. And so a lot of the Sandhill crane modeling that we've been doing, actually on top of it is beaver dams where those birds are actually breeding. And in fact, in southeast Idaho or southwest Idaho, in the Oahe, and exclusively in some places, cranes are breeding on top of beaver dam complexes, and they're very climate resilient because of that slowing of the water. They're usually upper elevations. And so working with producers to find ways where agriculture and water delivery can coexist together. When you put more water in that landscape, producers benefit as well. And there's a great story you guys probably have seen. It was one of our study sites in the research of Susie Creek in it's near Elko in Nevada. Did some grazing restoration there. Beavers came back into the system, and the ranchers there tell these amazing stories of Lahontan cutthroat trout doing really well. And during droughts, when all the other neighbors are trucking water to their sites, the folks that have beavers in their places are fat and happy because that water is still there because of the way those guys can re-engineer hydrology and store water underground where it can't evaporate. And it becomes available as things dry up on the surface, and cattle are happy, birds are happy, beavers are happy, and so are the fish. So beavers are a big part of a climate-based resiliency solution in the West. If we can get beyond some of the long-term perceptions of beavers being a headache for folks, I think we can do really well.
Wonderful. Well, Patrick, thank you so much. Doesn't look like anyone has any more questions. So I want to thank Patrick for being here with us this evening and sharing all this wonderful information. I want to thank all of you for attending. I love being able to do these virtual presentations and sharing information that our audience is interested in. In order to make programs like this possible, we do depend on our members and donors. So if you are so inclined to head over to our website and make a donation in support of programs like this, we would greatly value it. While you're at the website, you can also learn more about the Friends of Malheur, our membership programs, volunteer opportunities, and even sign up for our monthly newsletter, where you'll hear more about programs like this being scheduled in the future. So again, I'm Janelle Wicks. You can find me at friends@malheurfriends.org if you need to send me an email with any questions for any reason. And our website is malheurfriends.org. So thank you for attending, and I hope you all have a wonderful evening.